video, I wanted to go over some basic thoughts and some linearity to the channel. So I figured I'd walk through kind of like what I think where I want this channel to go. So let's talk about the basics. The design space portion of this, I didn't know whether or not to actually put this in, but then I figured anybody who may be wanting to start something like this may be able to use something that I'm doing here as reference, so it might be helpful in that regard. So I'll kind of walk through that. Then we'll talk about logical approach to whole projects. Things that I would like or need to build before I start working on some of these main projects, and then some of the main project ideas. So with that, we'll just jump right in. So when I'm designing, I prefer, obviously everybody has their own style, but I have my way of doing things. And one of them is to have a cleanish design area. And I say ish is because it's my own organized chaos. And you'll see pictures of this in a minute. But everything needs to be within easy reach. You don't want to have a process or a train of thought and then get derailed by that because you can't find something that you're looking for. My wife and I have kind of turned it into a drinking game. Every time I misplace something, we drink. It's a good thing we just drink a lot of water around here, otherwise we'd be drunk all the time. So everything within easy reach. That's going to be things like components, soldering equipment, testing equipment, some way of taking notes, jotting down test results, things of that nature, reference materials, data sheets, what have you. And then for me, a good catalyst is always good music, and then plenty of water. So yeah, blues is my absolute favorite, and yeah, that's a joke. We can still be friends. You lose cool points, but we can still be friends. So here's a picture of kind of the right-hand side of my design studio, I guess, if you want to call it. So the storage bins right here on the left wall are discrete components, things like resistors, capacitors, switches, so on and so forth. And then over here on the right hand side, the larger bins are going to be things like motors, pumps, Arduinos, Raspberry Pis, LCD screens, zip ties, things like that. Then on the brown shelf here, I've got two signal generators. This little one here was a kit I put together, and for like $7, it's actually not too bad. The one right there in front of the speaker. The big one next to it that was actually gifted to me by a ham radio friend. This is circa 1972, 73. Still works pretty nice. I'm pretty stoked that he gave that to me. Then I've got some Altoids tins that have various components that I use a lot of the times. Current limiting resistors for LEDs, 220 ohm, 330 ohm, so on and so forth, depending on the voltage you're working with. Batteries as an energy source, and then all the way over there in the corners are just some things that I'm slowly working on. And then down in the middle shelf, multiple colors, different gauges of hookup wire, solder paste, flux, other components, some surface mount stuff, kits like motor controllers when hooking up with an Arduino, things of that nature. Yeah, so you can just kind of get a feel for that. And then moving on, we get over to some of the equipment. We've got my benchtop multimeter, which also has a Bluetooth speaker built into it. I really thought that was kind of a gimmicky kind of thing, but I use it a lot and I enjoy it, and it's a fairly accurate meter, so can't go wrong for $100 on that one. Then to the left of that, I've got my soldering microscope. You can see the buck converter we just did in the previous video sitting underneath that. Then to the left of that, we've got the soldering station. So we've got a soldering iron, two different diameters of solder sitting on top of that, and then the hot air gun there. You'll get a better shot of that in the next picture. So yeah, there's the hot air gun. Then we've got the variable voltage, variable current power supply, solder tips up on top of that, my oscilloscope, and then the component tester sitting in front of that. And then this, I'll actually give kudos to my wife on this. She suggested whiteboard contact paper, and it's great for having to jot down quick things. Maybe you're taking, test results or something like that. Just write it down and do with it what you need to. I will say the only downfall about having that is when you're working on the bench and you're moving around, you're resting your arms, so on and so forth. It's easy to smudge that, so it's definitely temporary only. So, logical approaches. So everything that we're going to do is going to require some form of power supply. It needs to have the following attributes. It's got to be reliable, it's got to be stable, it's got to be efficient, especially if it's going to be plugged in 24/7. You don't want it wasting unneeded electricity, raising your bill. It's got to be easily repeatable, almost a copy and paste when you're moving it into other schematics. And it's got to be adjustable for whatever you're working on at the time. You may have a need for 5 volts for a microcontroller or 3.3 volts, but then in the same time, in the same breath, you also have a need for 12 volts to run, say, a stepper motor or a servo would run off 6 volts, but like a CAN motor in general. So this is why I'm spending the time designing this now, is because I know it's going to be used a lot going down the road. So most of the projects that we're going to be dealing with are probably going to need a microcontroller of some form. So most of the projects will require some form of input-output. You can think of input-output would be like button presses for a menu system, maybe touch screen, flipping a switch, reading in sensors, whether it's a temperature sensor, humidity sensor, you name it. There's just a ton of them. If you need to control motors, fans, relays, etc., the microcontroller is the best way to do that. Now, I don't know if I am going to go with the Atmega series, which is what the Arduino is based on, or if I'm going to try to do something a little higher scale, a little more powerful like the STM. Problem with that is I don't know anything about them. I don't know what kind of programming they need, so on and so forth. So that's something that I'll be looking into in short order as we move forward. Things that need to get done before, during, or as needed for main projects. So in the last video, I said that I was going to try the solder paste soldering with the stencil. I did try that, and it didn't come out very well at all. I wound up getting a short somewhere underneath one of the components. Don't know where that's at yet. I will find it and get it fixed, but yeah, so there's a need for, what's the best way to say this? I guess control and stability on the temperature. With the hot air gun, I haven't quite gotten it nailed down to what the temperature needs to be and how low the flow of air needs to be, because I wound up pushing parts around as things heated up, and as shaky as my hands are, I did a better job with that than I did with the hot air stuff. So a hot plate, I think, will be a better way to go. My hopes are that one of these projects that I wind up doing, people are going to want, which means mid-scale manufacturing. I mean, I'm not going to be doing anything on a large scale. Excuse me, at least I don't think so. However, for mid-scale stuff, anything over 50 or like 100 of them, it's going to be super time consuming to try to put those together by hand. So think of a pick and place machine as basically the same workings as a 3D printer. It'll move over, pick up a component, and then move it over to the circuit board and place it down exactly where it needs to be in the orientation that it needs to be placed in, and then go pick up the next part, so on and so forth. Then you can just, once all the components are placed, just pick up the board, put it on the hot plate, set it for its program, and it'll solder everything up, and it's all said and done. Something I'll probably need to do after that is testing solder joints and make sure everything's okay, but that can be another project down the road for whatever we're working on. So the next one, I guess I should have said that first. You've got the B, D, A-N. So B is before, D is during, A-N is as needed. So as needed would be a large volume 3D printer for enclosures. And you'll see why I may need this when we move on to the next couple of slides. And then studio updates to deliver content to you guys more easily. This is still very new to me, and I'm struggling with it. So I'll get it worked out, but it's going to take some time. So the main project idea I had: open source medication dispenser. As I get older and grumpier, fighting with medications is not something that I necessarily want to do. And every medical device out there is so expensive. And I'm not sure why that is. I don't know if it's the FDA. I don't know if people are just price gouging. I don't know. But it's way too expensive. So I want to do something open source that people can either buy as a kit, 3D print some parts if they've got it, and then just buy the electronics and put it all together, so on and so forth. It needs to do reliable medication delivery. That's going to be a challenge because every pill is unique in size and shape and weight, and getting it to dispense one at a time, that's going to be some design iterations to go through to get that right. I want it to have at least 12 medication slots, be able to handle multiple users because there's generally multiple users in a household. This one, medication reminders. So I was having a conversation with a friend, and they were discussing the fact that their child needs to take medication on a regular basis, but because of their condition, they sometimes forget. So they had brought that up that, it'd be great if they could get, a notification on their phone that says, hey, you've passed the scheduled time to take your medications. Please do so now. Would you like me to dispense it? And they could click a button and it'd be ready to go for them. The other one would be, medical lockout to prevent overdose scenarios. So specifically, I'm thinking elderly, people with Alzheimer's, so on and so forth. So there's that. So let me know what you think in the comments about this. Things to make it better, things that I haven't thought of here, that would be great. Other things that I've contemplated making: an open source continuous glucose monitor. This one would be very, very challenging. I read a couple of patent reports for existing CGMs out there. Apparently there are enzymes that are, I guess, fused to the sensor lead that interact with glucose and then turns that into hydrogen peroxide. That then gets read and a blood glucose value is determined from that. That is way over my head. I have no chemistry experience whatsoever, and my biology is lacking bad. Other options would be a Bluetooth speaker kit, weather station, temperature controller, ozone generator. And if you got any ideas, leave them in the comments, and we'll see what we can do with them. So that's it. And yeah, we'll see you in the next video.